In this lesson, we will be solving radical equations. We are going to start with a simple equation. 3 times the square root of x plus 2 equals 12. Now first, we must isolate the radical. And what that means is getting this part alone. To do that, we must divide everything by 3 on both sides. Then we get the square root of x plus 2 equals 4. Now we must apply the inverse operation. What that means is we must square both sides. We do this because there is a radical sign, and squaring it cancels it all out. After we do that, we get x plus 2 equals 16. Now, all we have to do is solve for x. X equals 14. Before we make that our final answer, we must always plug it back into the equation. Okay, good. It matches up, so our final answer is 14. Now we are going to try an equation with x on both sides. Usually we need to isolate the radical, but in this equation it's already isolated, so we just need to apply the inverse operation. So we square both sides, and that leaves us with x plus 6 equals, many would think x squared plus 16, but this is wrong. It is actually x plus 4 times x plus 4, which is x squared plus 8x plus 16. That's equal to x plus 6. Now we move everything over so it is equal to 0. And we get 0 equals x squared plus 7x plus 10. And now we just solve. We get x plus 5 and x plus 2. So x is equal to -5 and -2. So now that we found our two solutions, we have to check for extraneous roots or extra solutions. To check, we must plug in both solutions into the equation and see which one matches. So I'm going to plug in -5 first. Okay, so this did not work. So we're going to try -2. Yay, this one matches up. Now, many of you may think that because it equaled the square root of -5 came out to equal the square root of 1 equals -1, and yes, the square root of 1 is plus or minus 1, but we are always going to end up with the positive one to see if it fits, and because 1 does not equal -1, this was not the correct solution. Now, since we've done a couple together, here's a practice problem that you can do. So you need to pause the video, and when you press play, I'll have the answers up. Okay, here are the answers. X is 33/2, or 16.5. Now we are going to be doing a problem where the index of the radical is greater than 2. This problem is very similar to the others, so first we must isolate the radical, add 24 on both sides, and we get 8 square root of x minus 6 equals negative 24. Positive 24. Now we divide everything by 8. Now next, when we apply the inverse operation, instead of squaring it, we do the power of 4. And we got that number from the index. We do that on both sides, and we get x minus 6 equals 81. Now we solve for x. X equals 87. Now in this equation, the term with the rational exponent has a power of 1/3. Because the term is already isolated, we just need to get rid of this 1/3. To do that, we must multiply everything, power it by 3. We do that because the laws of exponents say that a power to a power you multiply, and 1/3 times 3 equals 1, and that's what we are trying to achieve. So after doing that, we get 2x minus 6 equals 512. And then again, we just solve for our x. X equals 259. Now to do an overview type thing, I'm just going to write out all of the steps that you need to follow when solving any radical equation. First, you must isolate the radical. Then you must apply the inverse operation. Step 3 is to solve for x. This is just simple algebra. And step 4 is to check your solution. This also includes extraneous roots, but that only applies when you have x equal to more than one number. Now I'm going to show you a way that you can check your solution with your calculator. First, you're going to go to graph, and in y1, put in one side of the equation. So, for example, the square root of x plus 4. And in y2, you're going to put in the other side of the equation, in this case 3. After hitting graph, you are going to see a graph, and where the two things intersect, your x is your answer. In this case, x equals 5. Thank you for watching. I hope you enjoyed and you learned how to solve radical equations.